Welcome back. Whenever I start running out of time, I rush things and I most probably confuse you. So let me go over that last example one more time. So I said I have a completely fair coin, and I'm going to flip it twice, and I want to know the probability that I get heads in both times. All right. Well, we already know that the probability that I get heads the first time is 1/2. There's 1/2 chance I get heads the first time, and there's 1/2 chance that I get tails the first time. And then I'm going to flip again. And let's say in this world, there's a 1/2 chance that we enter into this reality where the first flip is heads. And then in that world, I'm going to flip a coin again. And I know that there's a 1/2 chance of heads. And this is the second flip, and a 1/2 chance of tails. And I know in this other world, I'll just draw it just so we can figure out maybe other probabilities. I know that there's a 1/2 chance of heads. So this is for the second flip. And I know that there's a 1/2 chance of tails in the second flip. And just so you know, this is called a probability tree. And in general, it works excellent if you don't have, if you're not dealing with huge numbers. If you're not dealing with, I'm doing 100 trials, or I am doing, or the probabilities get really messy, or there's in each trial there's, 50 different circumstances that it can occur. When you're doing what, in this situation, there's 2 branches per, you could say, per node. So there's not that many circumstances that can occur on each trial, and we're not doing that many trials. So it's pretty manageable. And in these situations, the probability tree works really well. You can never get overwhelmed with the information then. And I'll show you. We'll do some pretty complicated examples using probability tree. There's no reason why I actually circled that with yellow. I just happened to switch to yellow. But anyway, just so you know, this was the first trial. That's the first trial, and then this is the second trial. This is the second trial. So we want to know the probability of getting here, right? Because we got heads on the first trial, heads on the second. Well, we know that there was a 1/2 chance of getting there. And then we know of that 1/2 chance, or half the times we got here, half of those times we would get there. So the probability of getting there is 1/2 times 1/2, which is equal to 1/4. Another way of thinking about it is each of these scenarios. So this is a scenario heads heads, right? Because you got a heads and then a heads. This is the scenario heads tails. This is the scenario tails heads, right? You got a tail, then you get a head. And this is the scenario tails tails. And all of these are equally probable scenarios, right? There's no reason why one is more likely than the other. And so we have 4 equally probable scenarios. So the total of equally probable scenarios is 4. And then how many of these equally probable scenarios, how many of these equal probability scenarios is our probability or our event true? Well, it's one of them, heads heads. So it's 1/4. So that's another way of viewing it. And another way you could view it is if we did this trial 100 times. If we did this 100 times, 50 of the times my first flip will be heads, right? And then of those 50 times, 25 of those times, right, half of those trials where I got 50 the first time will be heads again. And so 25 out of the total 100 trials will end up with heads heads, or this is 25% chance. I wanted to show you that all of these are pretty much equivalent, but I want your brain to kind of connect and make sure that it understands everything. So now that we've drawn this probability tree, I don't want it to go to waste. So let me give you another circumstance. What is the probability? What is the probability that I get at least? Let's the probability I get 1 heads and 1 tail. And notice, I'm not saying that it has to be in that order. It could be tails heads or heads tails. So this could be, let me write that down. This is equal to the probability of tails heads plus the probability of heads tails. Or we could write that as, and this is kind of with set theory notation, but it's good to be familiar with all of these. It's the probability of getting tail heads, or this U-looking thing, it means or in set theory, or the probability of getting heads tails, right? We can get tails heads or heads tails. In either of these, we're getting 1 heads and 1 tails. So what's that probability? Well, we can just look at all of the outcomes, and we know that there are four equally probable outcomes. And in how many of these is the event that we want true? Well, it's 1, 2, right? So there's a 2/4 or equal 1/2 chance where we do both of these flips, we get at least one heads and at least one tails. And I think it's a good time now that we've drawn this tree and we've talked about two flips in a row, to realize that these are mutually exclusive events. The reason why we can multiply the probability of the first event times the probability of the second event is because the probability of getting a heads the second time is completely independent of whether I got a heads the first time. And that might be obvious to you, but sometimes it isn't. Some people feel that if they got 5 heads in a row, that they're more likely to get a tails on the 6th time. But what we know from experience, really, is that no, it's not like the coin knows that you got 5 heads in a row and that it says, oh boy, I better give Sal a tails now just to kind of make up for all the 5 heads he got. It's equally probable to get a heads again. So that's just something to keep in mind. And it's amazing how just human beings, psychologically, you feel that if you have a big streak of heads, that you're due for a tails. But your probability of getting that tails does not increase. Although I will, if you keep doing it, your probability of eventually get the more times you do it, the probability of getting a tails does increase, and I'll show you that soon. That last statement probably confused you, and I probably shouldn't have said it. But so let's do an example. Now that we know that in mutually exclusive events, you can just multiply the probabilities. So let's say I have a fair coin, and what's the probability of getting 5 heads in a row? 5 heads in a row. Well, I have a 1/2 chance of getting heads the first time, then of those another half, then another half. So it's 1/2 times 1/2 times 1/2 times 1/2 times 1/2, and that equals 1/2 to the 5th power, and that's equal to 1/2 to the 5th power, and that's 1/32. That's the probability of getting 5 heads in a row. What's the probability of, I don't know, what's the probability of getting, let's say I were to flip a coin 7 times. So let's say I flip a coin out of 7 times, what's the probability of not getting any heads? Not getting any, and I'm going to switch colors just for the hell of it, any heads. Well, that might seem a little bit more convoluted to you, but just think about it. The probability of, out of the 7 flips, of not getting any heads, that is equal, what has to be true then? We got all tails then. That's equal to the probability of getting 7 tails in a row. 7 tails in a row. And what does that equal? Well, the tails are equally likely to the heads. So that would be 1/2 to the 7th power. And that equals, what is that? 2. So it'll be 4 times 132, right? Because so that's equal to 1/128. And here's a fun experiment to do is maybe in your classroom, or if you have a large group of people together, maybe 128 people, or some large number of people, and you make everyone flip a coin multiple times. By the end of 5 or 6 or 7 flips, there'll probably be, and later on we'll actually figure out the probability that there is someone who has a streak. But there'll probably be someone who has a very long streak of heads or tails. And that person will probably think that there is something magical about what is going on in their life at that moment. And it's important to realize that if you have a large room, if you have a room of 500 people, someone's going to be getting, there's a likelihood, and we haven't figured that out yet, but just given that you have a 1 in 128 chance of getting 7 heads or 7 tails in a row, someone's going to get it if you have 500 people flipping coins. But that person, since they just view their own reality, they think that today is their lucky day, and they think that they're on some type of streak and that they should go to Vegas. But that's just something that you should think about, because probability can often play with our brains. But anyway, I have 10 seconds left, so I will see you in the next video.